Hello, I am Jimmy Krozel, the Chief Scientist at the Innovation Laboratory. Today, I'd like to present to you a technology called intent inference, where artificial intelligence models are used to infer the intent of a pilot. Intent inference is a concept that I first investigated in my PhD thesis at Purdue University back in the 1990s, where I was the first person to define and publish a peer-reviewed theory for intent inference for piloted aircraft. I consider myself the leading expert in this field. At the Innovation Laboratory, we focus on research and development of new technologies that we can mature from TRL, Technology Readiness Level 1 to 6, preparing technologies for transition into government and commercial applications. One of the core competencies of our company is the transformation of surveillance data into actionable information for the warfighter. The surveillance data that we specialized in the most in the last decade has been ADS-B. That is, Automatic Dependent Surveillance Broadcast Data, which is the transmission of aircraft state data to other aircraft and to ground systems. Imagine that an aircraft is repeatedly broadcasting, "Here I am, I'm at this position, this altitude, and this velocity," and that they tell you this information every single second. This fire hose of data has a wealth of information contained within it beyond just the surveillance data itself. In fact, at the Innovation Laboratory, we have invented ways to derive valuable information from this data stream, including turbulence estimates for aircraft, as well as the intent of the pilot. The Navy SBIR program has recently requested that small businesses help to advance AI and machine learning technologies towards acceleration of mission success. Since ADS-B has been mandated by the U.S. by the FAA since 2020, and since it is the basis for much of the air traffic control for aircraft around the world, it is an important technology to exploit. Our quest was to exploit the fire hose of ADS-B data arriving at 1-second updates to infer the intent of pilots flying in the U.S. and around the world. We wish to identify if the pilot is flying 1, under nominal conditions, 2, off-nominal but well understood conditions, and number 3, under anomalous conditions with dangerous intent. For any application where the operator is responsible for monitoring large quantities of aircraft in real time, looking for off-nominal and anomalous behaviors of pilots, this intent inference software system can provide a second set of eyes for real-time monitoring. Automated intent inference monitoring can reduce the workload of monitoring air traffic and facilitates a shift in the focus of attention of the operator towards off-nominal and anomalies within an area of interest. In this SBIR effort, we have followed the intent inference theory originally developed by the principal investigator in order to define 110 artificial intelligence models that can explain the pilot intent in terms of nominal, off-nominal, or anomalous behavior. These 110 intent models are always observing the aircraft motion and constraints and always competing with one another to explain what the pilot is doing. The results from the intent inference models are immediately human interpretable, with labels like "the pilot is flying at steady level flight and constant velocity," or "the pilot is off nominal but simply avoiding a weather cell," or "the pilot is about to crash into terrain," or even worse, "the pilot is accelerating to crash into Camp David." Thus, instead of simply blinking an aircraft symbol on a screen and changing its color from green to yellow to red to indicate the anomaly status, we can explain what the anomaly is with simple, meaningful labels, adding to the situation awareness of the operator. We have progressed in developing intent inference software from TRL level 1 through TRL level 6. The original TRL level 1 was achieved back in the intent inference theory that was published by the principal investigator back in the 1990s. Most recently, in the Phase 2 SBIR effort, we have progressed to TRL level 6, demonstrating that the intent inference algorithms can operate in real time with live ADS-B data streams. Our proof of concept system is ready to demonstrate to you at your request. Please contact me for a private demonstration. We have built this software based on a well-founded theory of intent inference. The approach is scalable, scaling up linearly with the number of aircraft being tracked, the number of constraints, and the number of AI models. We have demonstrated that the software can work in real time. The system transforms large quantities of raw surveillance data into actionable knowledge expressed in human understandable labels. Furthermore, we've created an architecture that is modular and flexible, allowing for new AI models to be added or modified at any time. In fact, most of the AI models can be reused in new applications, with additional models added to address the specific mission needs. Ultimately, we have created a software that transforms large quantities of raw surveillance data and additional data like weather or map data into actionable knowledge that can immediately benefit the situation awareness of the warfighter. While we have demonstrated that our intent inference software can process real-world ADS-B data observed from everyday flights, and that we can detect cases for made-up synthetic anomalies for aircraft crashing into terrain or crashing into Camp David, there is still a need to test and evaluate this technology in a DoD-relevant environment to show that it is a viable enabler for mission success. Please work with us to pursue this next step. Not only do we see a benefit for DoD applications, we are also currently pursuing a transition of this technology into commercial applications with a commercial business partner. Ultimately, we feel that the AWACS or Hawkeye warfighters who are tasked with monitoring large quantities of aircraft surveillance data will benefit from this technology. However, any DoD application where large quantities of aircraft surveillance data needs to be monitored in real time to spot off-nominal and anomalous behaviors of pilots can benefit. Thank you for taking this time to listen to my presentation. Again, I am Jimmy Krozel, the Chief Scientist for the Innovation Laboratory. I would like to follow up with you on your interests in our technologies. Please take a business card and contact me. I look forward to a collaboration that accelerates your success. Have a good day.